Hello everybody, my name is Sparsh Bhatia and I'm in grade 9B. Today I'm going to be explaining the three different equations of motion. The first equation of motion is known as acceleration. It is the change in velocity upon time. Now, if we were ever to write change in velocity, we would need to know the total velocity. To find total velocity, we need to know the initial velocity and the final velocity. The initial velocity is written as a lowercase v, and the initial velocity is written as a lowercase u, and the final velocity is written as a lowercase v. So we would have to minus these, v minus u, to find the total velocity. And then we will put that upon time to find acceleration. And we can also find deceleration in the same way, because if v is smaller than u, we'll get it in a minus number, meaning acceleration in a minus will be deceleration. So that is the equation of motion. Next, we have the position time graph. Let me draw this for you. This is known as a position time graph. In this we have OA, AB, OC and CB or BC. Now, OA in this graph is the initial velocity, BC is the final velocity, and OC is known as time. This here is the formula to find the displacement. The area underneath the time graph itself will give us the displacement, which means this trapezium will give us the displacement. So now as a reference, v equals to u plus at. So using that, we can now solve this equation. S will then equal to half into time bracket u plus v. Then after that, again we will use the same half t into u plus, using this reference, u plus at. After that, we will get half into 2u plus 80, and S will then finally equal to ut plus half 8t square. So this at the end will give us the formula for the displacement. So we used all of this information to figure out the formula for displacement. Ut plus half at square equals to displacement formula. So what I showed you earlier is not the formula, but it actually is a equation to find another formula. The third and final equation is the displacement velocity equation. Now, as we know, S equals to half t into u plus v bracket close, and v equals to u plus at. Now that will mean t equals to v minus u upon a. Now we're going to substitute the value of t. Okay, so we're going to get S equals to half bracket open v minus u upon a into v plus u. Then, using the identity a plus b A plus B into A minus B, we will get A square plus, minus B square. So we will get S equals to half 2A, well, half 1 upon 2A into V square minus U square. V square minus U square will then equal to 2AS, which will then also will equal to V square equals to U square, V minus U square 2AS. Thus ending the three different equations of motion. Now we're going to be doing a numerical. As you can see, we have a question here. A train starting from rest attains a velocity of 72 kilometers an hour in 5 minutes. Assuming that the acceleration is uniform, find first the acceleration, then the distance traveled by the train for attaining this. So first we're going to start off by finding the given. So we're going to have to find V, U, and we already know time, so I'm going to write this down. Time is 5 minutes, which also equals to 300 seconds, because 5 into 60 equals to 300. V will actually equal to 72 kilometers an hour. And to find the find what 72 kilometers an hour equals in meters per second, we have to do 72 into 5 by 18, which then will equal to, which will then equal to 20 meters per second. And we don't have to do much for U because it says starts from rest, which means it was at 0 kilometers per hour, which means it will also be 0 meters per second. Now for the fun part, using the acceleration equation to find the acceleration. So we're going to use V minus U upon T, which will be 20 minus 0 upon 300, which will equal to 20 upon 300, or 1 upon 15. That means the acceleration is 1 upon 15 meter per second square, because we have used meter per second twice. And that meter per second square is the SI unit of it, of acceleration. Now we have to find the distance traveled by the train for attaining this. You can call it distance or displacement, because as far as we know, the train has only traveled one way from point A to B, and it's not going back from B to A, so displacement and distance have to equal to the same. Now let's find this. So like I said before, like I said before in the equation of motion, we can find displacement using ut plus half at square. So let's do it, shall we? Ut plus half into at square, or because I'm on an iPad, I will write it like this: t into t. So u here, as you can see, is 0, so 0 into time, and time, so it's 0. We can basically cut out ut. Then we'll have half into a. A is acceleration, so half into 1 by 15 into time, 300 into 300, which then using after cutting it all, we will get, after solving this all, we will get 3000 meters, which means we have found the displacement and we have found the acceleration. That means the question is finished. Thank you all for tuning in on this little study session. Thank you and have a good day. Stay home and stay safe.